Okay, welcome to my next video, dear students. In this class, we are going to discuss about the torque acting on a dipole placed in uniform electric field. Okay, so here I'm considering a dipole. What is a dipole? Dipole is two equivalent opposite charges separated by a small distance to a. Here we have a negative charge and here we have a positive charge, and I'm considering the electric field lines moving in this particular direction. Okay, so this is the direction of electric field lines, and we consider the electric field line always comes from a positive charge. Now, so the electric dipole of dipole moment P placed in a uniform electric field E, making an angle theta with it. That means this one is aligned in such a way that it is making an angle theta with the electric field. Electric field direction is this. This is dipole moment. It is making an angle theta with it. Okay. Now, the force experienced by the plus q charge. Okay. Plus q charge will experience a force that is equal to q into E. In the same manner, minus q, this is charge placed in this electric field, experience a charge but in opposite direction because of its negative charge. So direction of force will be in this particular direction. Okay, so because of that, what happens when it is placed in uniform electric field? It moves in this particular direction like this. It moves like this. Okay, so combining that, the net force on the dipole is given by F is equal to F plus Q plus F minus Q is equal to F plus Q is Q into E, and F minus Q is minus Q into E, opposite in direction but same in magnitude. So total force, the net force acting on the dipole, will be equal to 0. Then how can it move? Actually, we will not consider the net force here. We consider the couple or torque. Okay, here the two equal and opposite forces act at different points of the dipole. They form a couple which exerts a torque. Okay, we're going to consider torque here, not net force. So what is torque? What is the mathematical formula for that? So we are going to discuss about that now. Okay, so here I have the mathematical formula for that. So torque is equal to magnitude of either force, okay, any one of the forces, into perpendicular distance between the forces. Okay, so magnitude of either force means, so here we have F is equal to QE. Here also force acting on this charge is F is equal to minus QE, but if you take magnitude, it will become QE only. Magnitude is same but opposite in direction. And perpendicular distance, this is the perpendicular distance, 2a into sin theta. So that is QE into 2a sin theta, that is torque. Okay, so mathematically it is represented like this. Tau is equal to magnitude of force is Q into E, perpendicular distance between the two forces is 2a sin theta, that I have written in the diagram. So then we know 2a into Q is what? 2a into Q is it is dipole moment into E sin theta as it is. Then this will write as P, that is dipole moment, E as it is, sin is also as it is. Then we can write like this in vector form: tau is equal to P cross E. Okay, so ultimately the dipole formula is this. Then what if this dipole is aligned in such a way that P is magnetic dipole moment is along electric field? Then what will the force? See, force acting on this charge is in this direction. This is positive charge. The force acting on this charge will be in this direction when placed in electric field. So there will be no movement at all. If it is aligned with an angle like this, the force acting on this charge will be in this direction. It moves like this, and the force acting on this charge will be in this direction. So it moves like this. And here they stop because they are acting along this line. There will be no torque anymore. So when theta is equal to 0, tau is equal to PE sin theta. What is theta? 0. So sin 0 is 0. Total torque acting on the what is this dipole is 0. So in this case, when the dipole is placed in electric field, uniform electric field, then if theta is equal to 0, there will be no net force acting on it, and in the same manner there will be no torque acting on it. So torque experienced by the dipole when it is aligned along electric field where theta is equal to 0 is 0. So this is the one first case. Then here we have the second case also, where the dipole is aligned with theta is equal to 90 degree. So if it is 90 degree, the torque experienced by the dipole will be maximum. So tau maximum is equal to P sin theta. Theta is how much? The angle between dipole and electric field is 90 degree. So in place of theta we can put 90 degree. So sin 90 is 1. P is dipole moment and E is electric field. If you multiply that, you will get what is torque, and that will be maximum. Okay, so this is all about the theory of dipole. So let us solve a numerical problem on this. So here we have calculate torque of electric dipole moment 4 into 10 to the power 6 coulomb meter. This is not centimeter, it is coulomb meter. Do remember that. Okay, placed in an electric field of 10 into 10 to the power minus 4 Newton per coulomb. Newton per coulomb. With its axis making an angle theta is equal to 0 degree, theta is equal to 60 degree, and theta is equal to 90 degree. So according to the question, the given data is dipole moment is equal to 4 into 10 to the power 6 coulomb meter. Then electric field is 10 into 10 to the power minus 4 Newton per coulomb. Okay, then the total torque we need to calculate. What do we need to calculate? Calculate torque acting on the dipole at 3 different cases when it is aligned with an angle theta is equal to 0, theta is equal to 60, and theta is equal to 90 degree. Okay, so now theta is equal to 0. So that is the dipole is aligned like this. This one is negative charge, this one is positive charge. Okay, the total force acting on this is given like this. Tau is equal to P sin theta, theta is equal to 0, then this will be P into sin 0 is 0, so total torque acting on it is 0. Simple as that. Second case, tau is equal to P sin 60. So tau is equal to P is how much? 4 into 10 to the power minus 6. So here in the data I have written 4 into 10 to the power plus 6, sorry, it is minus 6. Here also you can change, it is minus 6. Okay, so into E is how much? 10 into 10 to the power minus 4 into sin 60, it is root 3 by 2. So or you can write like this, 0.8660. so if we solve this, we will get tau is equal to 34.64 into 10 to the power minus 6 plus 4 is 10. Unit is Newton meter, because tau is equal to force into displacement, Newton into meter. Okay, so this is the torque experienced by the charge when it is aligned with an angle theta is equal to 60 degree. So then if theta is equal to 90 degree, look at this, theta is equal to 90 degree, what is torque? Tau is equal to P is 4 into 10 to the power minus 6 into E is 10 into 10 to the power minus 4 into sin 90 degree. Okay, sin 90 is 1. So 10 4s are 40. So tau is equal to 40 into 10 to the power minus 6 into 10 to the power minus 4 will give you 10 to the power minus 10. It is Newton meter. Okay, so this is all about this torque. Thank you. Take care.